Hello, everyone. Thank you so much for taking your time in this evening to learn something about Azure. I would like to talk about take advantage of these performance tools in Azure. So, before even beginning, I would like to say that we are going to talk about Query Store a little bit, and a couple of the other uh, tools that are available in Azure to take advantage of. So and again, myself, I am Deepthi Goguri. I'm a database administrator. And thank you so much, Michael, for giving me this very nice opportunity. Whenever I ask you, like, hey, I would like to present at your user group, you always say yes. You never said no. Or you never said, like, hey, we have a lot of other speakers, maybe in somewhere in December. You never said that. You always give me a very near time presentation timing. So I'm so honored to be presenting at your user group again. Um, a little bit about me. Like I said, I'm a database administrator, and recently in October, I have been recognized as a Microsoft Data Platform MVP. I'm so honored. I really didn't think that I'll be able to get the award, but it is a very big achievement in my career. I can say that, and I'm also a co-organizer for a couple of user groups. I'm a co-organizer for Diversity, Equity, and Inclusion Group, Microsoft Data and AI South Florida user group, and recently I joined in Data TGIF user group as well. And I also do volunteer for Data Platform Women in Technology user group. And apart from my work, my community work, and my job, I love doing arts and crafts. It gives me so much peace. I build things with my own hands, and I really find peace in it. And if you'd like to contact me later, if you couldn't ask me any questions in this session, but later, if you have any questions, you can contact me at dbanuggets. That's my Twitter ID, and dbanuggets.com. That's my website. I usually blog about Azure, Query Store, and other SQL Server related stuff. You can view it if you would like to see more on it. And I'm very active on LinkedIn as well. Please type by my name, Deepthi Goguri, to get in touch with me. It would be an honor to, connect to you later. So when do you actually call it as a performance for your for your application, like client website or anything? When do they call it as a performance? We all know that when the queries run very fast, there are no latencies. We have proper resources on our SQL servers, and all the queries runs fast. There is no latency at all. That's when our performance is good. That's how we measure it, right? But when it is slow performance, then users definitely complain like, hey, the website is itself down. Maybe the website is not really down, but if they press on some query like store procedure that is running behind the website, connecting to the SQL server, for any reason, if there is any timeout error or whatnot, they always say like my website is itself down, right? So you get non-stop calls to the service desk. That's when that's when they say like slow performance, but there might be like several other reasons why the performance is slow. It can be any number of reasons, right? It can be network, it can be SQL server, it can be anything. So while you are building any new application, like if you want to build any database, what factors are really important for the performance, right? Um, the minimum list of things that we need to look into are like maximum capacities, um, based upon if you are having 24 by 7 application, or like whether you have like a certain period of time your application will be available and then nobody will be accessing it. Like for example, the timesheet applications, maximum capacities like memory, IO, CPU are based upon what kind of application you are building. And indexes, definitely, like if you know about databases, you know about indexes. Like for example, if you are building Azure SQL database or on-prem database, indexes are really important to retrieve the data. So maintaining those indexes, maintaining the statistics is really important. When we talk about in-memory OLTP, it's specifically available for business critical databases. Um, so for the business critical applications, you can use in-memory OLTP. And if you are building the databases in Azure, you can take the advantage of intelligent performance, which we are talking about in this session. So I'm not going to go through each and every point of on this slide, but I put things together, like what are the service tiers that are available in Azure and what are the compute tiers. We have general purpose, business critical, and hyperscale, and what are the maximum capacities are available, like compute and storage. And if you see the backups and whatnot, like what are the maximum capacities available in Azure for each of these service tiers and compute tiers. I have put this in a slide, so you can go through it. These are the maximum capacities. Some of the critical factors that are important while building a Azure SQL database is like we need to check the temp DB. So for Azure SQL database, if you have not already known, we can choose 16 files. For the managed instance, we can choose 12 files for the temp DB. You can choose the size and the number, but you cannot actually choose where the temp DB can be placed. And temp DB in Azure is always placed in local SSDs, um, always placed in local SSDs. And when we talk about the database configuration, databases are always in the full recovery model in Azure because of the SLAs that the Microsoft have to check. So it's always in the full recovery model, and you can use like alter database configurations. You can do that. Um, Especially for the query hints, there are like certain things that you can use for the when you are using the query store. There is a new feature available along with the query store is query hints that we are going to talk about in this session, where you can use the specific maximum DOPs for the specific queries. You do not have to touch the underneath code to use that feature, like for example, max DOP for the query hints. You do not have to touch the code, but without even touching the code, how do you use these query hints? We are going to see that in this session. And regarding the files and file groups in Azure, you can add and change the file sizes, but again, you cannot choose where those files are located. So first, let's talk about the basic things like indexes and maintaining statistics. On-prem, we know we have the SQL agent available so that we can run the jobs, right? For example, the maintenance scripts that we can get from the Ola Helen Green scripts, we can run maintaining indexes and maintaining statistics. But how do we maintain these jobs, maintaining indexes and statistics in Azure SQL? We do not have agent in it, right? So there are certain things that we can do, but like the points that I'm going to mention now, you might already know about it, but let me just brush it up for you. Maintaining indexes, like retrieval of the indexes is really helpful. Um, but what about the statistics? Like, why are the statistics so important for the query performance? Statistics are nothing but a sheet of tables that are available in the databases. It will actually show you how the data is actually flowing in the tables. So when you run a query, the internal SQL engine will actually go ahead and check the statistics, how the statistics are looking like, how the flow of the data is looking like. And based upon that, even before the query get executed, the allocation of the resources are released for the query execution. If the statistics are stale, right? If they are old, maybe like for example, when you are running a query, you need to get 3,000 records. But if your statistics are only showing like, hey, this query will get only 30 records, then that means like it will release the resources only for the 30 records because your statistics are stale. But when you execute the query, it will pull up 3000 records. So it will only release the resources for 30 records, but then it have to use more resources to grab the 3000 records. So it is the amount of resources that are going to be released for the query execution are released even before the execution of the query. So it is all depend upon the statistics. So maintaining the statistics are so critical. It's so important. And yeah, like when you rebuild the indexes, statistics will be also updated at the same time. Um, so how do we actually maintain these indexes and statistics in Azure SQL database? There are a couple of tricks you can use. You can use the Azure automation, and you can also create the Elastic agent jobs. Now let's go ahead and see how we can actually create these automation jobs. So before creating the automation job, you need to set up few prerequisites before creating the automation job. First, you need to have a certain amount of like automated scripts that can run, right? When you build this automation job, behind the scenes, it had to run certain scripts to maintain the indexes and statistics. So you can use the free tools that are available, like Ola, Hell, Grain scripts, or any other maintenance scripts that you have or that you have built in your internal company. Um, you need to have, of course, you need to have an automation account, and you need to download the SQL Server module from the marketplace, Azure marketplace. And after that, you need to create a credential. And after creating the credential, you can run the script and create the runbook. So to create the runbook, you need inside the script, you can create the variables, and then you can schedule the runbook. Whenever you want to run, you can run it. So here I placed screenshots of it. So I have actually installed the Ola Helen Grain scripts. You can go to the website, download it, and just execute it to create these store procedures. So I am right now connected to my Azure SQL database, which is AdventureWorks in my demo. So next, the next thing is you to create the automation account. It is very simple, few steps. Of course, you need to give a name and then subscription details, a resource group. You need to put each and every resource into a resource group. Where do you want to create this particular automation account? You are going to mention that. And then click on create to create the automation account. That's the first thing we have to do. And then you need to um, download the SQL Server module from the marketplace, Azure Marketplace. It is very simple. Go ahead and search for SQL Server module. You will get that, and you can actually install it. Just like you install any other tools, you can install it. And then you need to create the credential. Like I said, like whom do you want to run this particular job? So I have created the credential with my name. Next, you need to create the runbook. So check for the runbooks, like inside the automation account, you will be creating the runbook. Click on create runbook. And before creating the script, right, I do not want to hard code any values. I want to create the strings, like I want to create the variable. So I have created the database name variable, which is AdventureWorks, and SQL Server is like my Azure SQL database, dgtestserver.database.windows.net. Now I would like to, like, I have used the Microsoft Docs to grab the script. Um, so I have so basically the script will run the the maintenance scripts. Like it will go ahead, and if you see in the last few lines of the code, you can see it is actually doing operation on all the tables, and it is doing the Azure SQL maintenance. Basically, it is running those Aula Helen Grain scripts. I have provided all the variables, like what are the variables that I am using here. And then I will go ahead and schedule it. You can either manually run the runbook whenever you want, or you can schedule it and then click on create. So for example, I have created a database, AdventureWorks, and I have inserted a lot of data, which will actually make the data, like make the tables fragmented, like um, uh, make all the index fragmentation, and like I would like to run the job on these tables. So basically, I have inserted a lot of data so that the fragmentation will happen. So if you see the average fragmentation in percent, you can see like 99.99% on the indexes, if you see, and my statistics as well, they were never updated, if you see. So now I'll go ahead and run the run book manually. I'll do that. And once I run it, like if I go ahead and recheck my fragmentation levels are down, um and my even my like statistics are also updated. If you see the dates and times, like I have updated those as well. Job has actually taken care of those. The next important feature that I would like to discuss regarding the performance, like there is a query store feature that is available, like it is firstly introduced in 2016, SQL Server 2016, but since then they have made several modifications, and they have added like they have added the more features to it. So basically, what is this query store? So query store is a database level feature. It's not the SQL Server level feature. You need to manually go ahead and enable query store feature onto the database. So once you enable the feature, you will get a little folder inside the database as query store. So what do this query store do? Once you enable the query store on the database, it will go ahead and start collecting your queries. Whatever you are running, it will go ahead and start collecting your queries along with the execution statistics, like what is the CPU memory and all the resources that are consumed to run this query, along with the execution plans. So for example, if you run a query, it will go ahead and start collecting, and if a single query or a stored procedure have like multiple execution plans, it will go ahead and collect all of those execution plans over time, so that you can go ahead and see like how many execution plans are there for that particular query. And because you enable the query store, you have the advantage of going ahead and forcing a plan that you like. For example, if a query, like if a stored procedure have multiple execution plans, but then one execution plan is working better than the other, then by using the query store feature, you can go ahead and manually force that plan, so that the next time the store procedure runs with any parameter, it will go ahead and force that particular plan that you choose. But the other thing that you have to remember when you enable the query store is like you forced a plan, but then it's not like I forced a plan and now I'll forget, because there are several other factors that may affect the execution plans. Maybe later down the road, as the data is increased into the database, maybe some other execution plan that got generated may be better than the one which you forced. So you need to keep a constant look on execution plans that are getting generated, like, and are there any failures? Because sometimes what happens is like you will also see some failures when you enable the query store. Like you force a plan, and then you update the statistics or update the indexes, which will actually force the engine to generate a new execution plan, and your actual forced plan might fail. Like it might not use your query itself doesn't fail, but it might not use the forced plan. So there are like several factors that you need to focus when you are using query store. But then you at least have the ability to force a plan. And later down the road, like if you are in 2019 and 2019 above, and if you are in the enterprise edition of SQL Server, then there is something known as automatic plan correction, which is this slide. So automatic plan correction actually is especially available for the enterprise edition, and it is available. Sorry, I said 2019, but it is available from 2017 and above. So we have known like you can actually force a plan, right? If you are in 2016 and above, you can force a plan manually, and you need to look out for any other available better plans. But with automatic plan correction, if you are in enterprise edition, the query store will actually go ahead and monitor. You don't have to look for any plan changes. It will go ahead and actually look for all the plans like that are getting generated, and it will choose the best plan and it will automatically force that plan. And once it forces a plan, it doesn't stop there. It will go ahead and continuously monitor for any upcoming plans that might be better than the one that it has actually forced. Like if it finds a better plan, then it will go ahead and unforce the old plan and it will force the new plan. And if it finds like the new plan that got generated is worse than the plan that it actually forced, it will just go ahead and leave like that. Like it will always make sure the last good plan is the better plan. And it will make sure like it will always force the good plan. So you don't have to manually go ahead and look for those plans. Now let's go ahead and see the demo of automatic plan correction, how it actually works. So let me show you like so right now I'm connected to the Azure SQL database. If you see here, I'm connected to the Azure SQL database, and the database that we are using is AdventureWorks database. So basically, by default, like 2019 Enterprise Edition and above, as well as automatic plan correction is automatically enabled in Azure SQL database. So I would like to just show you like how we can actually do it through T-SQL. But if you are in Azure, right, you do not have to worry about it. It is automatically enabled. But if you are in 2017 and above, you need to manually enable that automatic tuning. It's available. So alter database, database name, set automatic tuning, force last good plan to be turned on. If you turn this on, like it will always make sure the last plan is always a good plan. So just to show you, like I'm executing this one. Currently, if you see, I'm connected to local server, but I would like to connect to Azure SQL database, not the local server. Okay, now I will just execute it. And then you can see if the automatic tuning is actually turned on by running this particular um, query, sys database automatic tuning options. Once I execute that, I'm connected to database. And then if you see the results, the force last good plan is turned on and the desired state is 1. So, and we are also going to see the create index and drop index. These also come under the automated intelligent performance features. So we can also enable those. These are also enabled. So let's first see the force last good plan to be turned on. So it's turned on. So now I will go ahead and create a very simple store procedure. So I'm dropping if this store procedure is already there, and I'm creating a very simple select statement and I'm searching on product ID. So let's go ahead and execute this particular store procedure in the database. And then now, before starting like executing our queries, let me go ahead and clear out my query store. If I have any collection there, I would just like to clear it out. And also I would like to clear my procedure cache, because if I have any execution plans in the procedure cache, my queries might go ahead and use those query plans in the procedure cache. So I don't want that. So I just want to clear everything out. and see how the automatic plan correction works. So now what we are doing is like, let me first show you like how the query store folder looks like if you're not familiar, right? So if you see here, Adventure Works database, um, you see, let me refresh. Wait, it is taking forever. I'm stuck here. Hmm. Okay, let me refresh. So if you see here, there is a query store feature, right? There is a query store folder. So if you expand that, you can see like all the other, like you can see the request queries, overall resource consumption, top resource consuming queries, and queries with forced plan. If you have actually forced any plan, you can see that here. So let's go ahead and see like top resource consuming queries, because here um, after we run the queries, we can actually see the details here. So right now we did not run anything, so we can see nothing here. So now let's go ahead and run this particular store procedure that we created for 50 times. Now why I'm doing 50 times is because we need to run the workload. Like if you run the store procedure one time, it takes some time for the query store to analyze the data, analyze the executions, and then go ahead and make the decisions. We do not have that much time, so we want to make the workload like running it for the 50 times. So let's see how many records we will get for um, this particular number 942. So let me run that and see the results. So it's executed successfully. Now let's go to the top resource consuming queries and like refresh button. Now I can see this bar graph kind of thing, and if you hover your mouse, you can see the query. But if you see the query, it is uh, it is not showing the exact query. It is in the parameterized format. If you see here, and if you want to see the query itself, like go ahead and click on view top consuming queries in the grid format so that we can see the query. If you see the query text, it is in the parameterized format. If you see here, and then you have seen the plan ID 1 got generated because we enabled the query store. It has actually saved this execution plan. So this particular query with the query ID 13, it has actually executed for 50 times, and it will provide all the details here like plan count 1 because only one plan got generated, and then like total duration and stuff. And if you hover your mouse over here, it will show you the details like total duration, average duration, and like all the other maximum duration details. And if you want to see other details, right, metrics, you have all the metrics here. You can see the metrics in whatever metric you want to see. You can go ahead and click on that and see. So right now we have executed that. And how many records did we get for each one? It's like, if you see bottom, 385 rows. So now let me go ahead and clear out my cache again, because this particular plan is already saved inside the plan. So I just want to clear it out to show you how the automatic plan, we are forcing the execution plan to create the new plan. So right now we would like to go ahead and create the regression. That means this parameter will create like way too many records. So I just want to run it only for 10 times, because this is like a parameter sensitive thing. So let's execute that and let's see the results. Like it will produce like huge number of records. Like it's still executing. We are running it only for the 10 times. And if you see bottom, 237K records each execution. So That's way too many, right? So let me go ahead and refresh this. So right now, if you observe, the plan number, plan ID 2 got generated, which is this one. But then like it compared both of the plans. And if you see a little tick mark over here, we did not do anything, right? We did not make any modification. We did not change anything from the query store perspective, but it automatically went ahead and forced this particular plan ID 1. And how do we know that it is being forced? Like you'll see the little tick mark. That means like this particular plan ID 1 is currently being forced. So if you want to see the plan ID, what it is and how it looks like, here is the plan ID 1. And if you'd like to see the plan ID 2, you can go ahead and click there. So plan ID 2, because it is generating like 237K records, it thought like it would be better to use parallelism, and it thought like it would be better to use the clustered index scan. And if you see the number of row count and everything, way too many records. So this particular execution with that particular parameter is like rare. Most of the executions are using the plan id 1. So it will go ahead and compare like 50 versus 10. It will go ahead and compare, like even we can manually compare both of the plans side by side. Now how do we do that using query store? Is like go ahead and click on shift key and select both of the plans, and then go ahead and use this particular compare the plans on the top right corner. Compare the plans for the selected query in a separate window. Once you click on that, you can go ahead and compare both the plans. Why did I, why might why did it might choose the plan ID 1 over plan ID 2? Is because the plan ID 1 is using index seek and a key lookup, and it is taking less number of resources. You can see the comparisons between both of them. This is obviously it is doing clustered index scan, which takes lot of resources. So we did not make any modification. It has actually went ahead and it has actually forced by itself. And that's how the actual plan forcing, like automatic plan forcing, will work. You do not have to monitor, it will continuously go ahead and monitor. And if you want to see the specific reason why it has actually forced that plan 1 and why it did not choose the plan 82, you can go ahead and run this particular query, select star from sysdmdb tuning recommendations. So if you do not have the automatic plan correction enabled, you can still run this query. You can still see the recommendation. You can still run this query, but you do not see any recommendations. Only if you have the automatic plan correction turned on, you can execute and see the results. So force last good plan is turned on. And what is the reason why it has actually choose the plan 81? So the average query CPU time has changed from 1.92 milliseconds to 735 milliseconds. So internally, we do not have the idea of how much threshold the CPU time have to reach in order for the automatic plan correction to be make the change. We do not know those like what is the threshold value, but it will clearly show you like what is the reason. Because the average CPU time has changed from this much to this much, it has decided to go ahead and force the plan ID 1. So if you drag your screen over here, it will show you, it will also give you the details. If it will give you the details, and if you copy these details, right? And then if you copy the details and if you paste it over here, it will clearly show you what is the query that you can actually run. If you drag your mouse and see, it will actually give you the script that you can actually execute by copying this query, sorry, by copying this code over here, right? Simply, it is saying like you can, I have actually executed it automatically, but if you want to see like what is a query that has actually executed, it will show you those details. Execute SP query store force plan, query ID is equal to 13 and plan ID is equal to 1. That is what it has actually executed. And one more thing I would like to mention here is like, if you are manually forcing a plan, please remember, always do that by using the store procedure, by executing this particular store procedure, sp query store force plan. To force a plan, sp query store force plan, and to unforce a plan, sp query store unforce the plan. Use those store procedures, and do not do that by using the graphical user interface, because your monitoring tools might not catch up if you are doing it through graphical user interface. Try to use T-SQL so that all the details will be captured. Now let me close this. Um, let me close this query, and then let me show you how the query store hints works. So one of the other performance benefit that you can gain from query store is using query hints. So what are these query hints? For example, we have this store procedure, this particular store procedure that we have discussed. It is like the store procedure have like sensitive parameters as well. Like most of the parameters use one query plan, but there are certain parameters that use completely different plan, because they are like they generate huge amount of data. So uh, there is no proper flow in the data. There are like up and downs in the data, like certain parameters get a lot of data. It is such kind of a parameter. It is such kind of a store procedure. So let's see how we can use the query store hints when we have parameter sensitive queries like this. So for example, if you have like let's see with this example, right? Let me go ahead and create the store procedure. I know we have created it before, but let me drop it and recreate it. And this is connected to local. So let me go ahead and connect to Azure SQL database again. So let me execute that in the database, AdventureWorks. You can use the query hints as well in Azure SQL database. So let me clear out my store, like query store, because previously we have executed certain queries. So I just want to clear it out. And when you see the top resource in consuming queries, now here, once you refresh, everything will be cleared out. I want to start it fresh. So I would like to also clear my procedure cache. I don't want anything in my procedure cache. Do not do that in production, because it will clear out everything, all the stored procedures, and all the execution plan for those stored procedures will be gone. Now let's see how this parameter actually, how parameter sensitive this is. So let me execute that store procedure with the 870, and let me see the include actual execution plan and execute it and see how many records it is generating. Now it is generating 360K rows. And if you see the execution plan, it is like in clustered index scan, it is doing okay. And we have those many records, right? 360K something. And now if you see this particular parameter 942 will just give like 385 records. And if you see the execution plan, because like if you see it, we only got the results 385 rows. Now why did it actually choose to do clustered index scan? It's because like the first execution after creating the store procedure, the first execution has generated like 385K records, and it have saved that execution plan in the procedure cache. The next time you run with any parameter, this is a general behavior in SQL Server, right? The next time you run with any parameter, it will go ahead and use the same plan, because it is getting that plan from the procedure plan cache, like from the procedure plan cache. We do have specific procedure plan cache, so it will grab from there. That's not good, because if you hover your mouse, it is doing clustered index scan, it is grabbing all the records, it is using so much resources not needed, right? So what can we do in this scenario if you do not have query store enabled? Like if you do not have query hints, if you can't use query hints, and if you do not have query store enabled, the only way that we do is just go ahead and um, just go ahead and like recreate the execution plan, right? Um, by using the hint, like to, I'm not remembering the actual hint. What can anybody say? Like, what do we use regularly to generate a new execution plan? I just forgot it. I mean, I don't know. Uh, what do we do? Like the option recompile, right? Recompile.
Yeah,
I'm so sorry.
yeah,
Like
with
the option
recompile.
recompile. Like recompile actually go ahead and it will refresh the execution plan. But how about like you have the query store now and you do not want to change any code. You do not want to because you want to use the query hints. To use the query hints, you have to edit the code. And for example, like you always do not have the option to edit the code because your client might say like no, you can't change the code. Now the performance is slow, you need to fix the problem, but somehow with resources and stuff do it, but you are not allowed to change any code. You are not always it is not always okay to change the code. In that scenario, you can use the query hints benefit of query store, right? So to use the benefit of query hints with the query store, you need to know the query ID for that particular store procedure that you are running. So I have actually used this particular string that we are using in the store procedure, product ID, and then I would like to go ahead and get the query ID for that particular query. Now, once you use this query and get the query ID, so this is the query that is actually running behind the scenes when you run the store procedure. So the query ID is 5. So what you can do is like you have the query ID. So by using this particular store procedure that is specifically designed for query hints, SP query store set hints, all you need is a query ID which is 5, and then you can give the value recompile instead of directly giving recompile. You just want to, you don't want to change any code, you want to do the recompile here. So let me go ahead and execute this. Now we have active hint that is available. If you run this query to see what kind of hints are available for the, this is the query hint ID 1. For the query ID 5, you are using the query hint option recompile, right? You can track it. But the disadvantage that you have is it will always only show the latest one, latest query hint. It won't show you the history of the hints that you have previously used. If you updated it, it will go ahead and give you the latest information. But there is a way you can actually get the history of the query hints that you actually used. I have written a blog post about it, how you can use extended events to capture that information. You can go ahead and see it in the dbanuggets.com and go ahead and select the query store tab where you'll see all the articles. And I have written an article about it. You can check that. So right now we have enabled the recompile option, right? So now let me go ahead and execute the store the this particular store procedure with the same exact parameters that we previously executed. And let me enable the mm, actual execution plan and execute it now and see the execution plans. Now, what happened is like previously, for the first time when it executed, it has to use the same execution plan the second time, right? Next executions. But here, because we did recompile, it went ahead and recompiled the store procedure automatically for you. These two are two different. It has recompiled, and for the second execution, if you see the results, it has only produced 385 rows and it recompiled and it has produced the exact correct execution plan based upon how many records it is generating, which is cool, right? Now, I would like to update update the same query ID 5 with max.1. Let me say like let's say like you can also change like max.1 or like whatever you want, like that is one of the hint you can use. Now let me go ahead and update the same query ID with this particular option max.1. And now if you go ahead and see like what are the options, like what are the hints currently available, like I said, it will only give you the latest one. The last one has actually updated, right? So it is only showing you maxed up one. Now how does that works? Now let me go ahead and execute one more time. Let me clear out my cache before doing that, and let me execute um, the same the same store procedure with two different parameter sensitive um, variables. Like now, if you see, it has actually run the clustered index scan first time and also used the same again because we have updated it. We are no more doing the recompile, but we have updated that to use the max.1. Now, how do you know that it is using the max.1? Is like go ahead and click on properties on the select and see somewhere here it should say max.set set to 1. And even for this, if you see max.is is set to 1. So we have updated, so the previous hints have actually gone. You can actually use multiple hints at the same time. Now I would like to use both recompile and maxstop at the same time. So I would like to update my query ID and use it. So let me execute that and then run the clear out my procedure cache one more time and then execute the same store procedure with two parameters and see. And now see, it has actually used both of the hints. One, it has actually updated the execution. It has recompiled the store procedure. And then the next one is like use max stop one. On both of the executions, it will update to max stop set to 1. So you can use multiple hints as well. Now, if you want to um, clear out the hints that you have actually enabled, execute sp query store clear hints and give the query ID. So executing that and then going ahead and selecting what query hints are actually enabled. Nothing is enabled. So now if you go ahead and run the same store, like run it again, it will go ahead and show you the normal behavior. So that's how you can use the query hints. Here is an article where you can go ahead and look into like what all query hints are currently active, and you can use like query hints in SQL Server 2022. And in SQL Server 2022, the behavior, like all that, like if you are creating any new databases, those new databases will automatically have query store enabled on them. And if you are getting the old databases, migrating them to the new environments, if you are doing that, then you need to make sure like you are enabling the query store on them, because those databases will not make any effect. Like query store will not be automatically enabled on them. You need to manually enable on them. But all the new databases will get that feature enabled automatically. Now let me go ahead to my slides back again. So we have talked about automatic plan correction and query hints, how they actually work with query store. Now let's connect to the Azure portal and see like how the other automatic automatic features available. So here we are using AdventureWorks database. We can also create the index and drop the unused indexes automatically in Azure SQL database. So that particular feature, you need to enable it. Let's say like I have enabled this particular option, like automatic tuning of the indexes enabled. So it will give the notifications once you enable it. If you see there, it says notification as 3, and it is showing like create index. Now once I click on it, it will show like a recommendation. One of the recommendation is to create the index, and you can see those underneath the intelligent performance. underneath the performance overview, you can see all of those recommendations. So once I click on that create index recommendation, it will show the recommendation description and what is the impact by creating that index, what is the impact. So it will first give you the report, and based upon that, you can go ahead and click on automate. On the top of the screen, you see automate. It will go ahead and automatically create those indexes for you. And if you would like to see more of like what the script and like on what table and what is the index type and schema, you'll get all of that information as well. And let's talk a little bit about the query performance inside that is available in Azure. So this comes under the um, intelligent performance. Underneath the intelligent performance, go ahead and click on query performance inside. So what this mm, uh, particular option will do is like it's like tracking all the queries. It will track the most resource consuming queries, long running queries. It will give like it will show as a chart, and it will show the query ID and like how much CPU, data, IO, what are the resources being used. You can go ahead and click on those query IDs to look more details into it, like how many resources are being used. So for example, here we have seen like query ID 61, 48, and 57. Now let me click on one of them, query ID 61. If you see, once you click on that, it will clearly show you like a query and what are the resources that are being used, so that you can go ahead and um, work on those scripts. Like maybe you can modify the query so that it will run better, but it will provide you all the resources like CPU data and log information like IO information. And I think I have covered most of the best features that are available in Azure and also in SQL Server, like what how you can use and improve the performance of your queries. I hope this session is bit useful for you. Maybe you have learned something new today. And I would like to thank Michael one more time for giving me this nice opportunity to present at your user group. Thank you.